In this very lesson, we shall be looking at the negative index and the fractional index of binomial expression. Remember, we are still on binomial theorem for rational index. So in this very lesson, we shall be looking at binomial expression of this nature. So in this very lesson, we shall be looking at a binomial expression with a negative index with what? A fractional index. Now, a binomial expression with a negative index or a fractional index, the expansion of this binomial expression is an infinite because the expansion does not terminate. So, expanding binomial expression of this nature, we mostly approximate it to some number of terms. Also, a binomial expression with a negative index or a fractional index, the suitable method to expand this binomial expression is the factorial approach. So this is a factorial approach with the first term being 1. In addition to this, when you have a binomial expression with a negative index or a fractional index, it is advisable to make the first term 1 when the first term of the binomial expression is not 1. So let's take it that you have, let's say, a plus, let's say, x raised to the power negative n. Now realize that the exponent of this binomial expression is negative. So as I said, it is advisable to make the first term 1. And we have learned this in a previous lesson. To make the first term 1, we are going to have a raised to the power n 1 plus x all over a raised to the power negative n. So when you have, let's say, 2 plus x raised to the power negative n, it is going to be 2 raised to the power negative n 1 plus what? X all over 2 raised to the power negative n. As I said, it is advisable to make the first term 1 so that we can use this factorial approach. However, the expansion of this is possible without this particular form. But since we are looking at this particular form, we are going to make sure that the first term is 1. So let's take examples and then see how best we can use it. So we have our first example. We have to expand 1 plus x raised to the power negative 3 up to the 4th term. As I said earlier on, when you have a binomial expression with a negative index, the expansion of that binomial expression does not terminate. That is why we are being asked to find up to the 4th term. Now from this, we realize that our first term is 1, so therefore we can use this factorial approach where the first term is 1. We know our n is equal to negative 3. So we are just going to substitute this into the formula. We know that our n is equal to negative 3. So we are just going to substitute this into the formula. So let's do just that. So we have 1 plus x raised to the power negative 3. So we have 1. Our n is what? Negative 3. And then our x is what? X. Our n is negative 3. Negative 3 minus 1. Our x is still x. All over 2 factorial. Then we have our n is negative 3. We have negative 3 minus 1. Negative 3 minus 2. And then we have our x is still what? X. All over what? 3 factorial. Now we have negative 3. Negative 3 minus 1. Negative 3 minus 2. Negative 3 minus what? All raised to the power 4 factorial. And then we have x raised to the power 4. But we are saying that we have to expand up to the 4th term. So let's count first term, second term, third term, 4th term. So we have to end at this lower part. So you don't have to go through the stress of expanding up to the 5th term. Our interest is up to the 4th term. So we can end at this lower point, and then let's bring our dots. So let's simplify. We have 1. This is going to give us minus 3x. We have plus, this is going to give us minus 3. This also giving us minus 4. And then we have x squared. All about 2 factorial is the same as what? 2. So we have 2. We have plus, we have minus 3, minus 4. We have minus 5. And then we have x raised to the power 3. And then we have 3 factorial is the same as 3 times 2 times 1. So let's do some simplification here. We have 1 minus 3x. These two cancel 4. We have 2. Negative times negative give us positive. Positive 6. Positive 6x squared. So you know that these 3 can cancel these 3. These 2 can also cancel 4. We have 2. So we have negative, negative. We have positive, negative. So we have negative 10 x raised to the power 3, and then we have our continuum. So it means that the expanded form of this binomial expression with a negative index is this particular part. Our task is to expand up to the 4th term. So we have first term, second term, third term, and 4th term. Don't go through the stress of expanding more than the 4th term, because the question says up to the 4th term. So we have our first example. Let's take our next example. We are to expand root of 1 plus 2x up to the term in x power 3. So we know that root of 1 plus 2x can be written as 1 plus what? 2x all raised to the power half. Remember that the root sign is the same as half. So when you have cube roots of, let's say, 1 plus 2x, it is going to be 1 plus 2x raised to the power 1 over 3. So with this 1 plus 2x raised to the power half, we have our first term to be 1. So we can use this factorial approach where the first term must be 1. So we can use this formula. So we know that our n is equal to what? Half. And then our x is equal to 2x. So we have 1 plus 2x raised to the power half. So we have our first term, which is 1. Our n is what? Half. So we have half multiplying what? 2x. We have plus our n is half. Half minus 1 give us minus half. All over what? 2 factorial. Remember, 2 factorial is the same as 2. And then we have x. Our x is what? 2x raised to the power 2. And then we have our n is half. Half minus 1 will give us what? Minus half. Half minus 2 give us minus 3 all over 2. And then we have 3 factorial is the same as 3 times 2 times half. And then we have 2x raised to the power what? 3. And so on. We have to expand up to the term in x power 3. And this term will give us x power 3. So we end at this very part. So let's do some algebra here. We have 1. This and that will give us what? Plus x. When you multiply this, we are going to get 1 over 4 minus all over what? 2. And then we have 4x squared. We also have the whole of that will give us minus, this will give us positive, so positive 3 all over what? 8. And this is over 6. So when you expand 2x raised to the power 3, we are going to get 8x raised to the power 3. So we have this. Let's continue. So we have 1. This is giving us x. Now you know that these two can cancel, for we have 2. So we are left with minus 1 over 4 and then 2x raised to the power 2. So we can do some cancellation here. These two can cancel, for we have 2. So we have minus 1 over 2x power 2 x squared all over 2 minus. And then we have, now let's work this one at this very place. So we have 3 over 8 all over 6 and then multiply 8x raised to the power 2. Now from here, 2 can go into 6, we have 3 and then we have 4. So we now have 3 over 8 raised to the power 3 multiplying 4x raised to the power 3. Now this can be written as 3 over 8 times 1 over 3 and then we have 4x raised to the power 3. This 3 can cancel this 3. This 4 can cancel 8. So we have 1 over 2x raised to the power 3. So the whole of this is going to give us x cubed all over 2. So that is that. So the expanded form of this is going to give you 1 plus x minus, let's make this one minus x squared over 2 plus x cubed over 2. So this brings us to the end of today's lesson. See you tomorrow. Bye-bye.